Hello class 9. In our last class, we have seen how to write down the electronic configuration of an element. So if atomic number and mass number of an element is given, then how we can write down the electronic configuration in terms of K, L, M and N cell. So you need to practice a lot in writing the electronic configuration and drawing the orbital diagram as well. Now today we are going to start a new topic of the same chapter, chemical bond. So now let us try to understand what does this mean. So a group of atoms which exist together as one species having characteristic properties is called a molecule. So when two or more atoms comes together and exist as a single compound having a characteristic properties, that we call it as a molecule. So the attractive force which hold various constituents, atom, ions, etc. together in different chemical species is called a chemical bond. So the force of attraction which holds the two or more atoms together in this way, okay, so they are called as chemical bond. We call it as chemical bond. Now in formation of chemical bond, they either follow octet rule or duplet rule. This is for the stability of an atom. Either an atom loses an electron or it gains an electron in order to have a stable electronic configuration. In doing so, the types of chemical bond they form are classified as electrovalent or ionic bond, and the second one is covalent bond. Now we need to study about details about these two kinds of bonds, electrovalent definitions, examples and the structure, how it is formed, similarly with covalent bond as well. So first we are going to see electrovalent or ionic bond. So the definition tells us the chemical bonds which are formed by the transfer of electrons from one atom to another atom are called electrovalent bonds or ionic bonds. So the chemical bonds which are generally formed by the transfer of electron, it can be one electron or more than one, from one atom to the other are called as electrovalent bonds or ionic bonds. Now the compound formed by transfer of electron is known as electrovalent compounds. So the compound which are formed by such method, say for example by transfer of electrons, we call it as electrovalent compound. And these are the examples of electrovalent compounds: NaCl sodium chloride, MgCl2 magnesium chloride, CaO calcium oxide, KBr potassium bromide, CaCl2 calcium chloride. So all these are examples of electrovalent compounds. Now we'll see the example of electrovalent compounds, how it is formed. So for that we have taken an example of sodium chloride. In sodium chloride we have got sodium and chlorine. Sodium atomic number is 11 and chlorine atomic number is 17. So when you write down the electronic configuration of sodium, it will be 281 because it has got 11 electrons. So that means in the first we have got 2 electrons, then in the second we have got 8 electrons, and in the last we have got 1 electrons. Similarly, when you write down the electronic configuration of chlorine atom, it will be 287, and if you draw the orbital diagram, it will be like this. The first orbit will have 2 electrons, K cell, then the second L will have 8 electrons, and the last one will have 7 electrons. Now both the atom needs to be stable. So according to octet rule, if an atom has 8 electrons in the outermost, it will be more stable. So what it will do is, sodium has got only 1 electron in the outermost, whereas chlorine has got 7 electrons. So if chlorine gain 1 electron, it will be more stable in the outermost electronic configuration, and if the sodium loses that 1 electron, the next orbit will have 8 electrons, which will be stable. So what it will do is, 1 electron from sodium is transferred to chlorine atom. In doing so, what will happen? The sodium is losing an electron. So an atom, if it loses an electron, it will gain a positive charge, that is a cation is formed, and an atom which gains that electron we call it a negative ion, or we call it an anion, and so in this case chloride ion will form. Now sorry, we have got positive and negative ions. So because of this positive and negative ions, they have got a certain force of attraction among them, and they will combine to form sodium chloride. This is how sodium chloride is formed by electrovalent bond. When you need to draw the electron or Lewis dot structure, what you can do is, we only consider the outermost electrons. Say for example, in case of sodium, if you see, it is 281, that means the last orbit has got one electron, so we have shown only one electron. Similarly in chlorine, if you see, we have got 7 electrons in the outermost, so we have shown over here only 7 electrons. So remember that while writing the electron dot structure, we only consider the last electrons. So over here what will happen, this one sodium electron will transfer this chlorine atom, so it will form sodium ion and chloride ion. So since because of these opposite charges, they will attract each other and they will form sodium chloride. This is how sodium chloride compound is formed, and this is how all the electrovalent compounds are formed. Next we have got covalent bond. The chemical bond that is formed between two combining atoms by mutual sharing of one or more pair of electrons is called a covalent bond, and the compound formed due to this bond is called a covalent compound. So covalent bond is that bond which is formed by the mutual sharing of electron between two or more atoms, that we call covalent bond, and the compound where you'll find this are called as covalent compound. Examples: hydrogen, oxygen, nitrogen, water molecule, ammonia, hydrogen chloride, HCl, CH4, CCl4. All these are examples of covalent compounds. We have got two kinds of covalent compounds based on the nature. One is non-polar covalent compounds and other is polar covalent compounds. Now let us first try to understand what is non-polar. Covalent compounds are non-polar when said pair of electrons are equally distributed between two atoms. So when there is a sharing of electron and if the electron pair is exactly in between the two atoms, that means they should have same electronegativity. So at that time no charge separation takes place. Such kind of compounds we can call it as non-polar covalent compounds. Example: hydrogen, chlorine and oxygen. So they are got similar atoms. So when you have got the similar atoms, they will be a non-polar covalent compounds. But when you see polar covalent compounds, the covalent compounds are said to be polar when the said pair of electrons are not at equal distance between the two atoms. So when the said pair of electrons, that means the electrons that are sharing, is not exactly in the middle or is not equally distributed, it might be happen that the electron pair might be shifted towards the most electronegative elements. Say for example, in case of water molecule, oxygen is more electronegative than hydrogen, so the electron pair will be slightly shift towards the oxygen atom. In doing so, what will happen? The oxygen will now have a negative charge because of its electron pulling power, and hydrogen will have a positive charge. Because of these two positive and negative poles, they are called as polar covalent compounds, and examples are water, ammonia and HCl. Next we have got covalent compounds. The electron dot structure. How to write down the electron dot structure of covalent compounds? Say for example, let us consider the first molecule, hydrogen. So each hydrogen atom has got one electron in the outermost. So what will happen? Both the atom need to be stable, and since it is the first K cell, the maximum capacity of K is only 2 electrons. If it can have 2 electrons, it will be stable. So what it will do is, it cannot transfer from one atom to another, because in doing so, what will happen? One hydrogen atom will be stable but other will not be. So what it will do, they will bring their each electrons closer to each other and they will share among them. Now this sharing of electron will give rise to a single covalent bond. Since there is two 1 electron sharing, it will give you a rise to a single bond. If there is 2 electron sharing, double bond, 3 triple bond, like that. So this is the electron dot structure for hydrogen molecule. We'll see other example as well as oxygen. Okay, if you write down the oxygen electronic configuration, we have got in the outermost 6 electrons, because electronic configuration is 2 6 electrons. So what will happen? 1 2 3 4 5 1 2 3 4 5 6. Okay, now on each oxygen atom we have got 6 electron, but we need to make it stable. That means 8 electrons in the outermost. So what it will do, if you do one sharing, only 7 electrons will be reached. But if you do 2 electron sharing, now this atom will also have 8 electrons. 1 2 3 4 5 6 7 4 5 6 7 8. Then this oxygen atom will also have 8 electrons, so that will be stable. And since over here we can see that we are sharing 2 electrons, it will give rise to a double bond. So this is the electron dot structure of the oxygen molecule. 6 electrons on each atom, and these 2 electron pairs are sharing with each other. That will give it rise to a double bond. Whereas the electrons which does not form a bond, they will remain on oxygen atom only, and they will be called as lone pair of electrons. So this will form a double covalent bond. One more example of covalent compounds: formation of ammonia molecule, NH3. So in NH3, what will happen? We have got nitrogen in the center, and we have got 3 hydrogen atoms. Nitrogen has got 5 electrons, 1 2 3, 5 electrons in the outermost and 2 over here. So it will say that 3 electrons which 3 hydrogen atoms. In doing so, what will happen? That will make it 6, and this 2 8, and hydrogen becomes 2. So the electron dot structure can be written in this form. 5 dots are for nitrogen, and the cross mark is for hydrogen, and there are sharing of electron among them. So it will result in the formation of this structure where nitrogen has got 1 lone pair of electron. That means the electron which has not formed a bond. So this is for the ammonia molecule. In this way, we'll practice with more writing of the covalent compounds, writing their electron dot structures. Now today's assignment number 6. Question number 1, define electrovalent bond. Question number 2, what are electrovalent compounds? Give examples. Question number 3, define covalent bond. Question number 4, what are covalent compounds? Give examples. Question number 5, differentiate between polar and non-polar covalent bonds. And finally, question number 6 will be, draw the Lewis dot or electron dot structures of the following: magnesium chloride, calcium oxide, nitrogen, water molecule, HCl, CH4, CCl4. So complete this assignment. And now today I am providing you a link. Through that link, you need to submit your answers for this assignment. Please remember that you need to submit your answers through a link, not in the email ID directly. So okay, so you'll go to that link. In that link, you need to provide your email ID. If it's not, you need to provide your parents email ID. Then you need to type your full name, your own name. Okay, and after that there will be a column add file. So there you'll go and click and select your PDF file. So this assignment you need to do in a copy. You click it, convert into PDF file. Remember that the form does not accept if you don't have the PDF format. Okay, so you'll submit over there, and once you submit, a response will be generated. That means a message will be received to you stating that your assignment 6 has been received. Okay, so if you don't know how to upload this, I'll share you a link, YouTube link, explaining how to upload the how to submit your assignments answer. And this is similar with our this will be similar to our midterm examination paper also. So when you do your midterm examination, the answer script will be submitted only through a link that will be provided to you. So please follow that thing. Okay, thank you.